There's a competition happening in Beijing right now that barely made international headlines, yet it might be more significant than any AI announcement from the past year. 16 nations, dozens of humanoid robots, events including soccer, track and field, and martial arts. It sounds like science fiction, except it's completely real. The world's first humanoid robot Olympics just concluded, and most people have no idea it even happened. While the world obsessively tracked every ChatGPT update and Gemini release, something quietly extraordinary occurred in robotics.
The field experienced what experts are calling a silent revolution, advancements in just 3 years that surpassed the previous decade of progress combined. And here's what makes this genuinely unprecedented. We're not talking about industrial robots performing repetitive factory tasks or specialized machines built for single purposes. We're talking about general-purpose humanoid robots that can adapt to dynamic environments, learn new tasks, and operate in spaces designed for humans. Robots that fold laundry, robots that load washing machines, robots working 24-hour shifts at BMW factories, robots that cost less than a used car. 10 years ago, humanoid robots from the DARPA challenge were slow, unstable, and cost $500,000 each. They were bespoke research projects that could barely walk without falling. Today, you can purchase a humanoid robot capable of acrobatics for under $6,000. That's not an incremental improvement. That's a fundamental transformation of what's technically and economically feasible. But the real story isn't just that humanoid robots suddenly work. It's why they suddenly work, who's building them, and how two completely different strategic approaches, American quality versus Chinese scale, are creating a race that will reshape manufacturing, elder care, domestic labor, and potentially the entire structure of human work. What follows is an examination of the technology that made humanoid robots viable, the companies racing to dominate this emerging market, and why the timing of this robotics revolution is directly connected to the AI breakthroughs everyone has been watching, the convergence that changed everything. The explosion of humanoid robots and the rise of generative AI aren't coincidental. They're causally linked in ways most people don't recognize. Think about what generative AI systems can do. They can see and recognize objects, images, text, and video. They understand spoken natural language. They can process multiple modalities simultaneously, vision, audio, text, and make contextual sense of all that information together. Now imagine plugging that capability into a physical robot body equipped with cameras and microphones. Suddenly, you have a crude approximation of human intelligence, or at least effective mimicry of it, that allows robots to perceive and understand their environments better than has ever been possible. Yes, generative AI systems occasionally produce errors when extracting precise information, but for robotics applications, the capability is good enough. And that good enough threshold is precisely what made the concept of general-purpose humanoid robots drastically more feasible than it was just 5 years ago. Robot foundation models built on transformer neural networks, the same architecture underlying ChatGPT and similar systems, combined with the generative AI revolution, allow robots to perform with dramatically lower failure rates even when real-world training data remains scarce. This is the technical breakthrough that unlocked everything else. Without the AI vision and language understanding capabilities that matured over the past 3 years, humanoid robots would still be stumbling research projects rather than increasingly viable commercial products. The American approach. Intelligence first. Let's examine what represents the current state-of-the-art in American humanoid robotics, because understanding the technical sophistication reveals why certain companies believe they can compete despite higher costs. Figure's O2 robot embodies the American strategy: build robots with exceptional intelligence and capability, then scale production. The robot recognizes and responds to natural language to execute actions. Its joints use custom motors, providing ability to carry up to 25 kilograms. Each hand features 16 degrees of freedom, with integrated motors and sensors in every finger. 6 onboard cameras provide 3D perception and environment mapping, and Figure O2 maintains a 360-degree field of view through cameras positioned in its head, torso, and back. The robot's brain, initially powered by OpenAI but switched to in-house AI in 2025, is called Helix. It's what Figure calls a vision action model, a proprietary system combining visual perception, language comprehension, and motor control into unified architecture. This means it can understand scenes, interpret natural language instructions, and translate that understanding into real-time continuous robot actions. Each robot operates two GPU-powered systems simultaneously. System 2 plans tasks at approximately 8 operations per second, while System 1 executes them at 200 operations per second. Figure claims each robot should pick up nearly any small household object, even items it hasn't previously encountered. The Helix AI was trained on 500 hours of robot teleoperation episodes, humans controlling robots, each paired with auto-generated text descriptions. This pairing allows the robot to link language instructions with appropriate physical actions. For walking, Figure employed reinforcement learning in simulated environments, training thousands of virtual robots to walk naturally before transferring that knowledge to physical hardware. Recent demonstrations show Figure O2 loading towels, crouching to access washing machines, and performing various domestic tasks with increasingly natural movement. CEO Brett Adcock stated in a podcast that, within the next 3 years, we'll definitely have robots piloting in homes. When Google's AI just works in robot bodies, here's something that sounds impossible until you see it demonstrated. Google's Gemini AI can be integrated into robotics hardware systems, and it works with minimal tuning required. At Google's I/O event, Carolina Parada, Senior Director and Head of Robotics at Google DeepMind, explained how this seemingly magical capability emerged. She leads a team that's been working on AI for robotics for approximately 7 years, building on foundational research spanning a decade. What they've developed is Gemini Robotics, a visual language action model that enables robots to see their environment, understand natural language requests, and take direct action. Gemini itself controls the robot's movements. The breakthrough is that all the multimodal intelligence already present in Gemini, its understanding of visual scenes, language, context, can be extended to a new language of physical actions. Parada noted that signs of this capability emerging only became visible about 3 years ago when large language models suddenly enabled semantic understanding. A robot could understand "I'm thirsty" as a request requiring specific actions rather than just processing words. Now, improvements in foundation models transfer directly to robotics capabilities. As Parada put it, "A lot of what you saw today, we didn't even work that hard to get. It just flowed out." Gemini is currently optimized for understanding the physical world, and Google is working to strengthen that capability further for direct robotics applications. The implication is staggering. As AI models improve for general purposes, robots automatically become smarter without requiring separate, specialized development efforts. The Boston Dynamics revolution. 10 years ago, Boston Dynamics' Atlas robot was unquestionably the most advanced humanoid robot on Earth, famous for agility, including crawling, jumping, rolling, and parkour that seemed impossible for machines. In 2024, responding to increasing competition, the company switched Atlas from hydraulic to fully electric actuators, improving efficiency and control. The robot now operates with 3 AI models distributed across 3 local computers, equipped with improved 3D vision and NVIDIA hardware for real-time AI execution. But the truly significant development came through collaboration with Toyota Research Institute. They created what they call a large behavioral model for Atlas. Here's the process. Collect behavioral data from teleoperation and simulation. Process, annotate, and curate that data for machine learning integration. Train a single neural network using all data across all tasks. Then evaluate performance. The breakthrough is that Atlas now uses one generalist AI model to control both walking and grasping. Previously, robots required separate models for different capabilities. Most models also lack adaptability, but this unified approach shows tantalizing signs of emergent behavior, like instinctively recovering when dropping objects. One researcher involved stated, "It's changing everything." Just as large language models fed massive text data sometimes exhibit unexpected abilities like coding, we hope similar strategies will produce robots exhibiting surprising new skills. In demonstrations, Atlas actively understands natural language and performs requested actions, folding chairs, tying rope, stacking cubes. The robot has been deployed to work at Hyundai Motor Group production sites, not coincidentally, since Hyundai acquired Boston Dynamics in 2021. The Chinese strategy, scale and speed. While America leads in robot intelligence and individual capability, China is pursuing a fundamentally different strategy. Mass production at scale, subsidized by the state, optimized for speed and cost rather than cutting-edge performance. And it's working. From iPhones to electric vehicles, China has spent 2 decades developing capacity to manufacture advanced hardware at unprecedented scale. As the world's factory, the country benefits from vast supply chains and streamlined production. China was the world's largest industrial robot manufacturer for years. Sales reached 90,000 units as far back as 2016, accounting for 30% of the global market. When the humanoid robot boom arrived, Chinese manufacturers were prepared. The International Federation of Robotics reported that over half of all robots sold globally in 2023 were made in China. The total value of humanoid robots produced in China is expected to reach approximately $616 million this year. Unitree's G1 model exemplifies this approach. Impressive balance, martial arts capability, dance routines. The G1 can walk, run at speeds reaching 7 kilometers per hour, jump, climb stairs, and even fold for transport, all at price points dramatically lower than American competitors. The 9,000 milliamp-hour battery provides approximately 2 hours of operation. Like American counterparts, the G1 learns from demonstration and reinforcement learning, refining balance and movements over time. Most processing comes from NVIDIA Jetson modules handling real-time AI perception. Chinese robotics firms like Unitree, Agibot, Galbot, Engine AI, and Fourier Robotics are proliferating rapidly. These companies appear everywhere, producing robots for entertainment, industrial tasks, even crime prevention in countries like Indonesia. The subsidization advantage. What gives Chinese companies significant advantages over American competitors is massive state subsidization. In January 2024, Beijing launched a $1.4 billion state-backed robotics fund. In July, Shanghai announced another $1.4 billion fund specifically for humanoid robots. That level of capital provides enormous head starts for dozens of companies simultaneously. China's strategic focus has led to a flood of robot patent filings, 5,688 patents, compared to America's 1,483 over a 5-year period. The Made in China 2025 policy aims to increase global market share of Chinese-made robots from 31% to 50%. Government initiatives like the Robot Industry Development Plan established infrastructure and expertise now being leveraged for humanoid production. This highlights the fundamental difference. In America, private sector capital investments lead development, resulting in higher quality but slower time to market. China is rapidly deploying robots everywhere, prioritizing ubiquity over perfection. While everyone obsessively tracked AI chatbot updates, robotics experienced a silent revolution that compressed a decade of expected progress into just 3 years. The convergence of generative AI with robotics hardware created capabilities that seemed impossible in 2020. American companies are building robots with exceptional intelligence, systems that understand natural language, adapt to novel situations, and learn continuously. Boston Dynamics, Figure, and Google are pushing the boundaries of what individual robots can accomplish. Chinese companies are building robots at scale, subsidized by state funding exceeding $2 billion just in major cities, filing thousands of patents, and flooding markets with increasingly capable hardware at prices dropping toward consumer affordability. The result is a genuine race with two completely different philosophies: American quality and intelligence versus Chinese scale and cost effectiveness. Both approaches are valid, both are advancing rapidly. The question isn't which strategy is better, it's which strategy captures market dominance first, and whether that dominance becomes self-reinforcing through network effects, data advantages, and manufacturing expertise. We're approaching a threshold where functional humanoid robots could cost $2,000, less than a decent laptop.
When that happens, the market transforms from experimental technology to consumer product, and the companies that reach that threshold first while maintaining reasonable capability will define the robotics industry for decades. The robot revolution happened quietly. Most people missed it entirely, but it's here, operational and accelerating faster than anyone predicted. The future didn't announce itself with fanfare. It just started walking, quite literally, while everyone was distracted watching AI generate text.